working with this one, we've got this angle of 31 degrees, right? The angle that you're going to use is going to dictate the side and how you label those sides. So what would you call X in regards to 31? Opposite. What would you call 41? That's the adjacent side, okay? So we should be able to say then that, or which trig ratio in SOHCAHTOA uses opposite and adjacent? Tangent, right? So we're going to say tangent of that angle, 31, is equal to X over 41, right? Now what do you do to solve for X? Yeah, multiply both sides by 41. It's going to leave you X over here, and so 41 over here, correct? Okay. So then, in Desmos, just type in 41, tangent of 31. Okay. Now, here's a situation where you could recognize that you are in the wrong mode, because that one gave me a negative angle, right? Okay. It should always provide a positive. Oh yeah, negative side. Sorry, negative side length. So here it should be a positive. So there, I knew I was in the wrong mode. Well, it won't always do that. Okay, it might give you a number that is positive, and you not know that it was the wrong mode. But always want to think about that when you're using the sine, cosine, tangent buttons. Could somebody have done this? Could somebody have taken this angle up here and called it 59 degrees? What would 41 be in regards to the 59? Opposite. And what would X be? Adjacent. So what would use opposite and adjacent? Tangent again. So I said tangent of 59 is equal to 41 over X. Now, the only thing that people don't like about this is the fact that X is in the denominator. But can I multiply both sides by X? And that will wipe away and give me X tangent 59 equals 41. And now this tangent 59 is just a coefficient, right? So to make it turn into 1, we divide by itself. Come over here, divide by itself. And I should get X to be 41 divided by tangent of 59. That should give me the exact same answer. 41 divided by tangent of 59, and you see that it is the same 24.6 value. Is that right? Okay. So if you want to do that, go ahead and do that. That's one of the properties of trigonometry that we need to have an understanding for, is that you can use either of the two acute angles with SOHCAHTOA and come up with a relationship that will solve for your missing side length. Now, I don't know that doing that on this is going to be much of a benefit because of where your variable is. Here, I'm going to have, well, let's label these sides. If I look at the 32, what is this side here? Opposite. And what is this side? Hypotenuse. So now I should be able to say the sine, cosine, or tangent. Which one? Sine of 32 is going to be 23 over C, right? Okay. Multiply both sides by C, and I get C sine of 32 is equal to 23. Now do what? Good. So I have 23, 23 divided by sine of 32. Okay. What do you notice? And if we went back to the last page, it happened there too. What do you notice about that object and that object in our answers? What did they do? They just switch spots. And that's always going to be the case, guys. If you get your variable down here in the denominator for one of these ratios and you're trying to solve for that variable, it just switches spots. So if you want to go through the algebra every single time, that's fine. If you want to make that shortcut, go ahead and do that shortcut. Okay. Now here's the idea: is that algebra is kind of a pain in the butt because the denominator is a variable. So the question is, well, can I look at this angle up here, which is 58 degrees, and see if I can come up with something that maybe puts a number here instead of a variable? So this side here would be adjacent, right? This would be hypotenuse. Which trig ratio uses adjacent and hypotenuse? Cosine. So I should be able to say cosine of 58 is equal to adjacent over hypotenuse. Does that make anything any easier? No. Where if we were to compare it to the last question we did, when we used tangent of 31 or tangent of 59, one of those was easier than the other one because of where the variable showed up. In this case, because the variable is the hypotenuse, it's always going to be in the denominator. But that's the argument, guys, that we said yesterday, or not yesterday, Friday, is that the sine of 32 is exactly the same as cosine of its complement, right? Okay, sine of well, we got these two equations here, 23 over c, 23 over c, those are equal. So sine of 32 and cosine of 58 should be equal as well. Okay, so either way you type this in, I'm going to have 23 up top and cosine 58 on the bottom. Either one of those is going to give you the correct value for that side length. Is that okay? We feel comfortable with those? All right, so the next series of questions incorporate something like this. And I'm actually going to give you some notes over this. So let's see here. All right, so if I look at that, now we're trying to find an angle, okay? So I'm going to give you some terminology here that is key for us. If I have addition, okay, that's an operation. What is addition's inverse? Subtraction. So addition, subtraction are what we call inverse operations. Okay. What about multiplication? Division. Okay. Again, inverse operations, right? Let's talk about some functions that you know, or some equations that you've dealt with. If I have square root of x, okay, what's the inverse of that? What? X squared is the inverse, okay? If I had the cube root, x cubed would be the inverse, okay? Those are probably the ones that you guys know the most about, but those are inverse functions. And we can use those inverse relationships to allow us to solve the equations, right? If I have the square root of x equals 5, square root of x equals 5, you guys know if I want to solve for x, I use the inverse operation, or the inverse, I guess here, relationship. And those are going to cancel, leaving me just x, right? And 25. You know, if I had like 2x plus 3 equals 10, you're going to do subtraction. That's the inverse of addition. And then you're going to do division, because that's the inverse of multiplication, right? So you get 7/2, okay? So the same thing happens when we're talking trigonometry. We have inverses, okay? We have procedures that will undo another concept, okay? So if I have, for instance, we've been dealing with, let's say, the sine ratio, okay? And we know the sine ratio is a comparison of the opposite side and hypotenuse through division for a given angle. So for instance, if I have sine of 30, we know that that ratio of the opposite side divided by hypotenuse is going to be 1/2. Okay? There should be a relationship that says, if you know the ratio is 1/2, can you give me the angle? Does that kind of make sense? When I type sine of 30 on my calculator and it gives me the 1/2, that's saying that there's a ratio that goes with 30. Okay? Well, when I want to reverse things and say, okay, the ratio is 1/2, what's the angle that goes with that? We have what we call the sine inverse. Okay? So I write this down, sine inverse. Okay? Provides an angle measurement provided, or let's say based off of, a known ratio. Let's put opposite over hypotenuse here. Okay. So it's kind of like working backwards from what we did on Friday and Thursday. Okay. We're going to start you off with the ratio, and you work backwards to find the angle that goes with it. Okay. And here we're going to need to use our calculator to help us with this. But there's some notation here that's going to be important for us to deal with. The notation is that right there. Okay? It's sine with a superscript of a -1. That is not an exponent. It's not a power or anything like that. It's just a notation thing to tell us that that's what we talk about as for an inverse. Okay? We can do the same thing for cosine, and we can do the same thing for tangent. Okay? There are other words that you might see used. Okay? One of them is arc sine. The other one is arc cosine and arc tangent. Okay? So arc sine is the same thing as saying sine inverse. Okay? Arc cosine, same thing as cosine inverse. It's just different ways of saying it. I believe the arc sine, arc cosine, arc tangent format, that notation is old world, kind of like before the advent of technology and calculators and that kind of stuff. They use that notation. The sine inverse notation, the stuff on the left with that -1, kind of lends itself to a little bit maybe better algebra or easier algebra. But standardized testing, they may ask you or present you questions using both formats. Okay, so it's nice to know that those are the same. All right, so how do we use this? Wow. Well, I'm just going to delete all this. All right. How do we use the sine inverse function? If I want, let's say, sine of, we should put x here, equals 1/2. We already know this should be 30, right? Okay. The algebra that we go through looks something like this. Okay. If I want to get to that x, I want to pull that out and have that only on the left-hand side. Well, the way we do that, it's much like if I had square root of x is equal to like 2, you would square the left-hand side, right? And that is going to leave just the x. And the squaring is the inverse of the square root, okay? So over here, it's a little bit more obvious that the sine inverse is the inverse of the sine. If I do that, the sine inverse and the sine are going to wipe each other out and leave me with just x. Okay? Then if I do that to the left-hand side, don't I have to do it to the right-hand side? So then on the right-hand side is going to look like this, sine inverse of 1/2. And that gives you exactly what you need to type into your calculator. Okay? Now, making sure that you are in degrees. But if I hit, now you're at the functions tab here. You're going to go find the inverse column, so sine inverse, and then just type in 1/2. And it should spit back to you the angle that we knew we should have had already, right? So that's kind of a trivial example to see that we're mimicking something that we already knew to be true. Okay? Is that all right with everybody? So let's see how we can do that with this problem here. Okay. First thing you do is you still label your sides based off of x. So what side would this be? Opposite. What side would this be? Hypotenuse. So this is a situation where I'm still going to use sine, correct? Okay. So sine, I'll put x here, is equal to opposite, which is 15, over hypotenuse, which is 23, right? All right. So if I'm trying to solve for x, I'm going to take the sine inverse of this side, and then I'll take the sine inverse of this side. What's that going to give me over here? Just x. And this side here is, just type in sine inverse of 15 over 23. And that will give me the angle. Let's do this way. 15 divided by 23. There's my angle of 40.7 degrees. Is that something we can do? Might want to write this down. Okay, to find side lengths, you're going to use the sine, cosine, tangent, okay? Because those are defined ratios for a particular angle that they provide you with that are going to allow you to kind of enlarge or shrink, I don't know that word, enlarge or shrink the current side length that you do have information about, okay, to gain the one that you're looking for. If you're going to try to find an angle measurement, then you already know the ratio. You already know the comparison of sides. So you're going to use the inverse functions to see what the angle is that is associated with those ratios. Okay. We kind of did an exercise in the last class. I think it probably makes a little bit of sense to kind of do this. There was a triangle. Let's say that I have this triangle here where I look at that x. Let's say this is 6 and that's 13. All right. If I go 6 divided by 13, I get that number right there, right? So there should be a sine of something. I'm going to start with 30 degrees. That might get me something close to that. Would you say that 0.5 is close to 0.46? Okay, so but I know it's not 30, so let's try 29. Is that closer? Let's try 27. That went too far, right? It went below 0.46. So let's go maybe 27.5. Okay, that's a little bit better. Now we're out to that 7 being the first place that we see something different in this number, right? So maybe it's 27.48. Okay, maybe something like that, okay? So I'm starting to get further and further out to figure out what that number is, what that angle measurement is. But the inverse, instead of doing that kind of guessing game, does that make sense? Everybody see what we're doing here? Instead of playing that guessing game, we can actually say, what is the sine inverse of 6 divided by 13? And it gives me exactly what I need. You know, I was using 27.484. It ends up being 27.4864. That would be that angle measurement. Does that make sense? Okay. So that's what those inverse buttons are going to do for you. It becomes pretty useful. Okay. So anybody have questions on that? We're all on the same page on how to do that? All right. The last question. Use this relationship, okay? It says the cosecant is 1 over sine, okay? That's the definition of a reciprocal, folks. If I have let m be a rational number. Now, it doesn't have to be rational. Let's just say be a real number. Okay. Then 1 over m is its reciprocal, provided m does not equal 0. Okay? That's how we define what a reciprocal is. It's 1 over your number. Because if it's 1 over m, let's say m is 2/3. Well, 1 divided by 2/3, okay, looks like this, 1 over 1 divided by 2 over 3. And the way we actually do that division, dividing by a fraction, is the same as multiplying by that fraction's reciprocal. That gives me 3/2. Would you guys agree that 2/3 and 3/2 are reciprocals? Yeah, okay. So, when we look at cosecant being defined as 1 over sine, secant as 1 over cosine, cotangent 1 over tangent, this is just a way of saying cosecant is sine's reciprocal, secant is cosine's reciprocal, cotangent is tangent's reciprocal. Okay? Now, if we know that sine of, let's just say, x is opposite over hypotenuse, cosine of x is adjacent over hypotenuse, tangent of x is opposite over adjacent, what do you think cosecant of x is going to be if these two things are reciprocals? Right, hypotenuse over opposite. What about this one? What is secant going to be? Hypotenuse over adjacent, correct? And then tangent is going to provide cotangent as the reciprocal, which is adjacent over opposite. Okay? And if you want to view it that way, okay, maybe this is x here. If you want to view it and do it that way and memorize those three, that's fine. It's 100% nothing wrong with that. I think there's better ways of doing it. I'll leave that up there for you to write down. But I think maybe if I look, let's just do sine of A. Okay, if I look at A up here, what is the sine of A? If I look at A, if I'm looking at that angle, this is opposite, this is adjacent, this is hypotenuse, right? So sine of A would be 16 over 20, wouldn't it? We can reduce it to save time. I'm not going to. What would cosine of A be? Be 12 over 20, right? Adjacent divided by hypotenuse. Tangent of A, let me write it over here. Find a better place to write it. Tangent of A would be 16 over 12. Is everybody okay with that? Okay. Now I'm going to go through, and now that I have those, now I should be able to determine what their reciprocals are. Okay? Sine and cosecant go together, and they are reciprocals. Okay? So sine is 16 over 20. What's cosecant? 20 over 16.
Pardon the interruption, but Coach Behrens wanted us to pass along a message to the boys tennis team. You are to report to the high school gym tonight at 7 p.m. through the baseball diamond doors. Again, boys tennis team members, you are to report to the high school gym at 7 p.m. tonight through the baseball diamond doors. Thank you.
Secant would be what? 20 over 12. And cotangent would be 12 over 16. Okay? In regards to remembering those guys, I think most people are going to agree that tangent, cotangent are easy to see if they go together, right? Okay? Tangent, cotangent, basically all relationships that we ever talk about should always kind of pair up together. It's just a unique relationship. Sine, cosine, secant, and cosecant. There's two that have S's, there's two that start with C's, right? The S's never get paired together. We're talking about reciprocals. The S's never get paired together. The C's never pair together. Does that make sense? And that should allow you to always determine which one is which one's reciprocal is belong together. Okay. We got a worksheet for you for this evening. I'm going to extend 8-3 through tomorrow. I'm going to put some more more opportunities on it. If you struggle with these last ones at the end, now you go back and redo them and answer them hopefully correctly. This worksheet is due tomorrow, but we're not doing the whole thing. So hold on a second. You don't have to if you want to. So that worksheet, you're doing the evens. In questions 27 and 29. You're doing the evens, 16 total. Okay, evens and 27 and 29. Potentially, not for the night. All right. If there is, I'll be able to open it for you when you get back. Thank you too. Careful, Randall. It's a tricky environment in here.